A for accommodation, B for Bhorbury, C for carry on, D for distribution. What are we talking about ABCD in today's session? Yes, students, we are going to study ABCD of some particular topic in today's session. Don't worry about this. You will come to know in short while from now. But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all. Every accomplishment starts with the decision to try. So what are we waiting for when the success is ahead? So no need to worry and grab the success, children. Now, the ABCD of today's session, that is the objective of today's session, is how are electrons distributed in different orbits from Chapter 4, Structure of an Atom. This we are going to start today. Now students, little bit of retrieve, that is recap, we will be doing it to start with a new particular subtopic of this chapter today. Students, you must have heard about the scientist name, that is Rutherford. From Rutherford model of an atom and Bohr model of an atom, we understood that what is an atom. In an atom, electrons and protons, electrons and protons are present. And then later on, the discovery, that is, the discovery of the third subatomic particle, neutron, was also done. Now, in the nucleus, that is, which is the center of an atom, in nucleus, we have protons and neutrons. And these protons and neutrons collectively are known as nucleons. And the electrons are always revolving around the nucleus in their energy shells, which are named as K, L, M, N, as shown over here on the screen. Oh my God, what are these two boys doing it over here? What are they doing over here? Hey Tom, you are sounding very low today. I don't feel like doing anything. Just want to rest. No energy at all today. I am at stable stage. Yesterday I was very energetic, unstable, that is in highly excited state. Oh dear Tom, you are feeling the same way as an atom. When an atom has lower energy, the maximum stability is there. You are having the same feeling today. Seeing their conversation today of these two boys, Harry and Tom, I recalled my mind. That means something is coming which I read in the last video too. That is about the stability. I studied about this. The energy of the electron is minimum in the orbit nearest to the nucleus, that is K shell. The energy of the electron increases as it moves away from the nucleus. For example, if E1, E2, E3 are energies of K, L, M shells, then E1 is less than E2, is less than E3 and so on. As long as the electron remains in the orbit, it does not lose or gain energy. This means that energy of an electron in a particular orbit remains constant. That is why these orbits are called stationary states. Oh yes, now I recalled. Yes, now I know about the stability, about the stationary state of an atom. Okay, now students, we come to the topic where we have to learn about the accommodation, arrangement or distribution of electrons in a particular shells around nucleus in an atom. Now children, whenever we have to show the accommodation of electrons in a particular shell, how we will come to know that how many electrons are there in particular shell? That is a big question mark and a matter of worry also, how to go for it. So, first of all, you need to understand about the word electronic configuration, which we also write it as EC. So, the distribution or arrangement of electrons in the different shells of the atom is called the electronic configuration of elements. Now, the first rule says how to fulfill, how to distribute the electrons in shells. The first one says the maximum number of electrons that can be accommodated in the outermost orbit is 8. That means the outermost shell will always have 8 electrons. Electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner, which we discussed, previously also. The maximum number of electrons present in a shell is given by the formula 2n square, which is a magical formula where n is the orbit number or the energy level. Now let us see. Okay, now we are going to start that how electrons distributed in different orbits or energy shells. Yes, it was suggested by Bohr and Bury. And it was a matter of worry, a big question mark that how we are going to accommodate the electrons in different shells. So Bohr-Bury said, don't worry about this. I have a rule, scheme or a system. That means I have one magical formula which is said to be 2n square. With the help of this formula, we are going to fulfill, that means distribute the electrons or accommodate the electrons in all the 4 shells which are known as K, L, M, N. Now, let us start with the rule, how to accommodate the electrons. Now, the rule says we have a magical formula 2n square. So, how we are going to do it? Okay, I will take n is equal to 1. I will put the value of n is equal to 1 in 2n square. So, after putting the value of n is equal to 1 in 2n square, what I will get? That is 2 into 1 square is equal to 2. That means these 2 electrons will be accommodated in the first shell, which is known as K shell. Now, it says that when n is equal to 2, I will put the value of n is equal to 2 in 2n square. So, what I will get? Please calculate. 2 into 2 square is equal to 2 2s are 4, 2s are 8. That is 8 electrons in which shell? That is the next shell which is known as L shell. Now next, when n is equal to 3, I will put the value of n is equal to 3 in 2n square. So, after calculation, I see that I get the number 3 3s are 9, 2s are 18. That is 18 electrons in M shell. Now, next, the last, that is when n is equal to 4, I will put the value of n is equal to 4 in 2n square. I get, after calculation, 2 into 4 square is equal to 4 4s are 16 into 2, 32. And this will be n shell. So, in this way, I got the accommodation of electrons in all the 4 shells named as K, L, M, N. And This is also known as electronic configuration, abbreviated as EC. So whenever you see the word EC, it is nothing but the electronic configuration. And electronic configuration says the accommodation of electrons in different shells according to the formula 2n square, which is a magical number given by Bohr-Bury. So this is the best way of showing accommodation of electrons in different shells. That means you need to follow the rules to accommodate the electrons. So next, now children, to understand in a better way, of course, we need to understand the examples also, which is really very, very important. Now we have understood about the accommodation of electrons in different shells. Now let us take an example. So the first example I would like to take as for sodium. Now sodium symbol is Na. We all know, children. What is the atomic number of sodium? Yes, we know it. It is 11. Now, how to accommodate the electrons? Of course, now what I will do? I will write down the electronic configuration as I told you earlier. Now, what I will do in the first shell? Now, I will write down K, L, M and N. Now, first thing you should know that the atomic number of sodium is 11. So, this number 11 has to be, we have to accommodate in different shells. But according to the rule given by Bohr-Bury, which we did just now. So, we will see in the first shell, how many electrons were accommodated? 2. So, immediately we will write 2 over here. In the next shell, how many electrons were accommodated? 8. So we will write 8 over here. Now we will add up 2 plus 8, that is 10. And what is the atomic number of sodium? 11. So that means the accommodation of electrons will always be by seeing the atomic number of the particular element, because the example is over here sodium. So the atomic number of sodium is 11. So these only electrons which is showing atomic number will accommodate in different shells. It will not be more than 11. It will not be less than 11. So always take care. The accommodation of electrons will be only and only the atomic number of a specified element. So here we are doing it example of sodium. So atomic number is only 11. And this only atomic number 11, which is total number of electrons, will be shown the distribution of electrons in different shells. So 2, 8 and what is left? 2 plus 8, 10 and what will be left? 1. So I will write 1. So I don't want the last, that is the fourth shell over here, because the electrons, the atomic number of sodium has been fulfilled in these 3 shells only. So in sodium, we have only 3 shells, K, L, M, and the distribution of electrons 2, 8, 1, which is known as EC. So this is the way how we show the accommodation of electrons. Am I clear, children? And the last shell is known as over here M shell only, and the last shell is also known as valence shell. We will study in detail about this valence shell valency in the next coming up videos. The next example let us take of chlorine. So what is the symbol of chlorine? That is Cl. What is the atomic number? Of course we know it. Atomic number is 17. So what is the electronic configuration? Electronic configuration, let us write, that is K, L, M, N. Let us first write down the shell's name and then I will show you the accommodation of electrons in different shells. According to the Bohr-Bury concept, that is taking the magical formula 2n square which we studied just now, we will go according to it about the rules.
So the first shell will accommodate only and only 2 electrons. The second shell will accommodate only and only 8 electrons. Hold on, let us see. That is 2 plus 8 is 10. And how many electrons or the atomic number of chlorine? 17. So that means it cannot be more than 17. It cannot be less than 17. We cannot do on our own because the atomic number of chlorine is 17. We will only and only accommodate atomic number 17 in different shells according to the concept 2n square. So the third shell will have only and only 7 electrons left. So we don't need this fourth shell over here because the electrons has been distributed in only and only 3 shells. So no fourth shell required over here. So the accommodation of electrons, that is electronic configuration, is of chlorine is 2, 8, 7. Finished. So this is the way, children, that you have to accommodate the electrons in different shells with the help of the magical formula 2n square. So please, children, revise on the daily basis, which is really very, very important to note about the electronic configuration, about the magical formula, about the steps to be followed, how to accommodate the electrons in different shells. So with this, I wind up the session. So have a nice day. Bye-bye. God bless.